Well, the US space agency NASA has successfully launched a spacecraft which is designed to crash to succeed. Its aim is to test new defence technology designed to deflect speeding rocks that could potentially collide with Earth in the future.
Liftoff of the Falcon 9 and DART.
Lighting up the Californian sky, NASA takes its first shot at cosmic billiards. Tucked inside its rocket is the DART spacecraft, on a mission to crash into an asteroid in the hope of nudging it off course. It's a test run, but one day the strategy might be needed to save the planet from a catastrophic impact.
I do sleep well at night. I don't overinterpret or stress about the hazard, but it is something that's out there. And if you could prevent an earthquake or a hurricane, you want to have that technology in place. And this is a situation where we could potentially prevent a natural disaster. And that's why we want to have this technique in our back pocket, proven in space, so it's there if we need it.
DART's target is Dimorphos, a space rock 160 metres across, which is orbiting around a larger asteroid called Didymos. In September next year, it'll smash into the rock at 15,000 miles an hour. It should nudge Dimorphos into a slightly shorter, quicker orbit, which scientists should quickly see as it spins around its twin.
An asteroid a little larger than a football pitch would wipe out a city and the region around it. The good news is that NASA hasn't seen anything yet that we need to lose sleep over, certainly not in the next 100 years. The bad news is they reckon they've only catalogued 40% of the significant near-Earth objects out there.
Here it comes.
When there's no gravity to hold things down, even small objects can have a disproportional impact, as demonstrated by astronauts on the International Space Station. No need to resort to nuclear bombs to divert an asteroid, as favoured by Hollywood disaster movies.
If you're going to send a nuclear bomb up, you're probably not going to be able to send it so far away as we would need to because of the energy it takes to get the nuclear bomb up. So you're going to be hitting the rock quite close to the Earth. If the bomb does what it's supposed to do, which is break up the big rock, then the Earth will be hit by a whole shower of radioactive rocks, which is not much of an improvement.
Space rocks collide with the Earth every day, but rarely are the meteors as large as the one that exploded over Russia in 2013. That wasn't even 20 metres across, yet it caused extensive damage, and NASA says it's best to be prepared for even worse.